So to finish up 2.6 notes here, we're going to go through a few examples, 5, 6, and 7. And number 5 is kind of like a puzzle, taking it apart or putting it together. So it says in calculus, it's important to be able to identify two functions that make up a composite function. And so we're given an h of x here, and the h of x is in our directions. And then we want to find possible answers because there's many possible, but we will give the most simplistic answer of two functions f and g that would be combined together to make this h of x function here. And so what we're going to focus on is the inside function and the outside function. And that's the easiest way to decipher these is think what's inside, that would be your g of x function, and then what's around that, what's on the outside of that, that's your f of x function. So let's go through these few examples. So in letter A, what I notice is inside is 3x minus 5. So I would call this the inside function. So I would say g of x is 3x minus 5. And then outside of that, the only thing outside is the cubed. So that means my outside function, my f of x, is x cubed. So what we did then is we put this 3x to the 5th into the x to the 3rd and made the h of x function that we were given here. So my answers for g of x and f of x would be g of x is the inside, the 3x minus 5. F of x is the cubed, so x cubed, that's on the outside. All right, so let's do the same thing for letter B. Let's look inside, outside. So here we have a fraction, and that's okay. So what I notice that's inside is the 5x plus 2, inside the parentheses. So my g of x, my inside function, is 5x plus 2. Now everything that's around that is a 4 in the numerator and the squared in the denominator. So my outside function, this is what's on the outside of that. My f of x would be a 4 in the numerator and then a squared in the denominator, and I have to say that that's x squared because that's what got replaced. So your outside part can be a fraction. It could be a square root. It could be an absolute value. It could be anything. Okay, one more like that. So here we have the 5th root. So inside, we've got the 9 minus x. So that I would call my inside, the g of x. And then outside of that, we have the not the cubed root, the 5th root. So my outside function, my f of x, would be the 5th root. And then I would say whatever's inside is my x value. So there is letter C. So this is called decomposing because you are taking the combination and picking it apart into two functions. Okay. Number 6, we're going to use a graphing utility. So we're going to use Desmo. So go ahead and pull up Desmos on yours. And what we're going to graph is f, which is down here, f of x. We're going to graph g, and we're going to graph f plus g. So we have to say that f plus g would be our f of x, x divided by 2, plus our g of x, square root x. And we can't combine anything, so we're going to graph this as well. So on Desmos, you're going to type in those 3 functions and get the graph. So go ahead and switch over to Desmos and do that. I'll show you what it looks like here. Okay, so here we have our 3 functions, and you can see my first function, f of x, is red. The second function, g of x, the square root of x, is blue. And then when they're added together, that's the green. So use the color coding to help you. And what the problem is asking you is when you have the addition. So when you look at the green function, so we're looking at the green function specifically here, which of the other functions, f of x or g of x, so I'm going to label the blue is the g of x, and the red is the f of x. Which one of those impacts the magnitude the most? And what that means is, when you're looking at the graph, which one is closer to the addition? Because whichever one is closer is impacting it more. So when we look on the scale or on the interval from 0 to 2, that's from 0 to 2 here. So just looking in this chunk, the green function is closer to the blue function, and that's the g of x. So between 0 and 2, g of x is impacting the magnitude more. Okay? So, and then when you look where x is greater than 6, so if we focus in 6 and more, that's this piece. And if I look in this chunk, the green function is closer to the red function, which is the f of x. So after x is greater than 6, the f of x function is impacting the sum more. So on a question like this, when you're looking at the graph, you're looking at which original function is closest to the function where you are adding the two together. Okay, then the last example gives you a couple graphs and wants you to evaluate either the combination, which is 7 and 8, or the combinations, which are 7a and b, or compositions, which are 8a and b. So for number 7, what you're doing is you're subtracting and you're using 1. So if you piece this apart, this would be f of 1 minus g of 1. And so what that means on your graph is when the f function, so here we have the f function, here we have the g function. On the f function, when x is 1, y is 2. So this would be 2 minus. And then on the g function, when g is 1, y is 3. So this would be a 3. And then just take 2 minus 3, and we know that is a -1. So you're using the graph to figure out if x is a certain value, because remember, this is your input, this is your x. What's the output? And then combine them together. So for letter B, we are looking at f of 4 times g of 4. So I'm going to figure out what those two values are, and I'm going to multiply them together to get my answer. So for f at 4, the y value is 4. And for g, when x is 4, the y value is 0. And 4 times 0, anything times 0 is 0. Now, when you're doing composition like number 8, you need to do one at a time. So for example, here we're taking g of 1 and getting that answer and then substituting that answer into f. So g of 1, if I go to my g function where x is 1, the y value is 3. So that's 3. And then we're doing f of that value, which is 3. So on the f function, when x is 3, y is 2. So composition, you have to do one at a time. So then for letter B, f of 3, which we actually just found, f of 3, remember where x is 3 there, y was 2. So f of 3 equals 2. But then we're going to do g and use 2 and get our final answer. So g of 2, when x is 2 on g, y is also 2. So you can use graphs and use your inputs, which are the x value, to determine the outputs, which is the matching y value. Your assignment here sorry about that. There's your assignment, page 219. These are all odds, so you can check them all. And like I've said before, make sure you write these down carefully. Pay attention to the ones you should be doing. Use your notes to help. And of course, as always, ask me if you need anything.